Today we're going to continue with some geometry, but we're going to be moving away from the idea of volume and area and things that we were doing in our last unit. And we're going to start this unit by taking a look at some angle relationships. And I thought today we would start by doing a review of some of the things we did in 7th grade regarding angles and triangles. So before we start, I just want you to look at this page here and notice that at the bottom I've got this mathematical tool, which is called a protractor. It's used to measure angles. And that's what we're going to start with, is talking about angles. So an angle has what's called a vertex. That's the point where these two rays start from. They have a common end point, and that end point is called a vertex. Now, angles can have all kinds of different measurements, and we see 3 kind of angles represented on this flip chart. So you'll notice that this angle, which measures 55 degrees, so if we put that protractor up there and measured it, we would see 55 degrees. That's how much, say, a door is open. It's open part way, so this would be the door, and say this is the wall, and you can see the door is open part way. It's 55 degrees. It's less than 90. You can see this green right here would make what's called a right angle, which is represented right here, and that would be a 90-degree angle. You can see that by the degrees, but you can also see it by the little box in the corner, and that would be if the door was kind of open, perfect to that 90-degree angle. Over here, we go past the 90-degree. My door at school can actually go past that before it hits the wall. And you can see that this angle goes beyond the number of 90 degrees and is about a 120-degree angle. So we're going to talk a little bit about these angles again. So let me show you the next slide. And here are some of the names. So before I go over and kind of show you these kind of live, remember that an angle that is less than 90 degrees, so as a number smaller than the 90, is called an acute. Acute little angle is how I think of it. An angle that is exactly 90 degrees is called a right angle. And once we go beyond that 90 degrees, it's called an obtuse angle. When we stretch that angle out so that it's a straight line, so we open all the way to here, you can see the straight line, that would be represented by 180 degrees, and that's called a straight angle. There are 2 other angles mentioned here that I will just mention. If you were to go all the way around and keep pulling it all the way around, you see there's 306. That's called a reflex angle. And then a full angle is the idea that you would pivot completely around the circle, which is 360 degrees. So a circle has a 360 degrees, and an angle is basically a piece of that circle. We are going to talk about acute, right, obtuse, and straight. These ideas will be used later on, but I thought since we were taking a look at them, I could at least mention them. Let me just go out here and just kind of show you. So there is your acute angle. There's your right angle. Waiting for that obtuse. Not coming. There we go. There's the obtuse angle. I don't know why everything's so slow here. Bigger than 90. And there would be our straight angle. Now, if I take this little slider, you can kind of see that as I move things in, the angle will get smaller, until I'm back to an acute angle, and then I can literally bring it down to barely having that door open. So acute angle until we get to a right, which would be exactly 90 degrees. And then when we go past the 90 degrees, we're going to see an obtuse angle like 120. And when we stretch it completely out into a straight line, which is called a straight angle, it's 180 degrees. I am just going to show you again, what does it mean by this term reflex? If I push that even further around, that angle that started and then comes all the back around would be 230 degrees, and a full angle would be the whole 360 that I come right back to where I started. So those are the names of the angles that we've talked about in the past. Last year, though, we learned a couple of things about angle pairs. So I just want to review those with you. The first pair of angles that we talked about was the idea if we take two lines and we make an X, that if we look at opposite V's, so I'm going to trace this top angle. See me tracing it with my cursor, that top angle like it's opening up, and then I'm going to trace the bottom angle, which is opening down. So angles 2 and 4 are opposite V's, and they are called vertical angles. We have another pair of vertical angles, the one that is opening to the left, which is the angle 1, and the one that's opening to the right, angle 3. They are also a pair of vertical angles. Now, the cool thing about vertical angles is that they have the same number of degrees, they have the same measure, and in geometry, when two figures have the same measurement, they're called congruent, and we use the little equals with the kind of little S on top. That's the symbol for congruent. So angle 1 and angle 3 are congruent. If you were able to cut them out and put them on top of each other, they'd match perfectly. Angles 2 and 4 are also congruent. If two angles are next to each other, now I want you to think of your house, your apartment, and your neighbors. And if it's two houses, you share a boundary line. So if you look at angle 1 that I'm tracing right now, and if you look at angle 2 that I'm tracing right now, they share this boundary line. Like between my house and my neighbors, we have a fence. And on the other side, we have a wall. So those two angles, if they're next to each other, they're neighbors, they're called adjacent. Now notice that angle 1 and angle 3 are not adjacent. They don't share a property line, a wall or a fence. They're across the street from each other. Those are vertical. So let's talk about adjacent again. Adjacent means neighboring or next to. So angle 1 and 2 are adjacent. Now let's go to angle 2. Angle 2 and 3 are adjacent. They share this ray. Angle 3 and 4 are adjacent. They share this ray. And angle 4 and 1 are adjacent. They share this ray. Now, adjacent angles are not necessarily congruent. They don't necessarily have the same measure. I mean, look at angle 2. It's an obtuse angle. Angle 3 is an acute. They are not equal measured. But what you do know is that they add up to a straight angle. So if you take this measurement and add it up in this particular picture, those two adjacent angles would actually add up to a straight angle. We're going to talk about that more in a minute. But please note that 2 and 3 are not equal measure. 3 and 4 are not equal measured. One of them is obtuse and one of them is acute. So they do not equal each other. Vertical angles, opposite V's, do equal each other. They are congruent. Now, the way you name an angle, there's several different ways. So let's just review that by using last year's book. I'm going to use this guided practice. And we're going to take a look at this angle and see if you right now can remember how to name that angle. And oh, by the way, there are 4 ways. So if you want to pause the video for a second and just think about that or write them down, go ahead. I'm going to review that in just a second. Okay, so 4 different ways to name this angle. The obvious one is to call it angle 2. The next one is to name it with its vertex point, which is angle E. And remember, we use that little angle symbol. You don't have to write the word angle out. So you could call this angle E. Now that can be dangerous, and I'll talk about that in a second. But that is a second way to name it. You name it by its vertex point, the point where the 2 rays end. You wouldn't call this angle D. You would only call it angle E. Now the other way, and the best way to name an angle, is using 3 letters. So if I start at the F and trace the angle, go to the E, and then the D, we could call this angle FED. Now I could have started at the D and gone and traced the angle and called it angle DEF. Those are the 4 ways to name the angle. I would not name it FDE. That is a different angle. When you are naming an angle using 3 letters, the vertex, that endpoint, has to be the center of attention. So it has to be in the middle of the naming. Now, I mentioned a second ago that calling it by one letter can be a little dangerous, and that would be the case if you had more than one angle at that point. So if you kind of look over here, there's a center point right here that say that had been an E, and you say angle E. Which angle do you mean? This one on the left, the one on the top that's 100 degrees, the one on the right, or the one on the bottom? So naming an angle by a single letter is fine if it's only one angle, but if it's in the center of a picture where there's more angles going on, then you really don't want to use that single letter. This guy is an acute angle, and there are the four names to name it, four ways rather. Okay, so now we're going to take a look at this picture. And another question we dealt with last year was, finding this x. Now I want you to look at the top angle that's opening up. That's 100 degrees. It's an obtuse angle. It's bigger than 90. And the angle below is 2x plus 4. These two angles are opposite v's. They're vertical angles, so they will be equal to each other. So we could set up a little two-step equation. We could come over and Woodruff bubble this, if that sounds familiar. I hope it does. Subtract 4 from both sides, get 2x equals 96. Undo the multiplying by dividing by 2, and the x would be 48. If you take 2 times 48, you get 96. Add 4, it would be 100 degrees. So in order for these two to be equal, which they must be because they're vertical angles, the x would have to be 48. Okay, so they're just asking you to look at the railroad sign over here and name a pair of vertical angles and a pair of adjacent angles in the picture. So if you want to pause and just take a look and think a second before I give you those answers, that would be great. Okay, so there are two pairs of vertical angles, 2 and 4, and angles 1 and 3. There are 4 pairs of adjacent angles, which would be 2 and 3, 3 and 4, 1 and 4, and 1 and 2. They're just giving you one over here. Vertical angles do not overlap, and they are opposite v's. Adjacent angles are right next to each other and share a side. So that is the difference that I just mentioned. Vertical angles are opposite, and adjacent angles share a common side or vertex. So what I'm hoping you have right now is to remember how to name an angle, remember vertical angles, and adjacent angles. Okay, next up, we added 2 other pairs of angle relationships in 7th grade. One was called complementary and one was called supplementary. Complementary angles add up to 90 degrees. Now, when you see this little m in front of the angle, that means the measure of angle 1. That little m is an abbreviation for the word measure. So when you're talking about degrees, you put the little m in front so that everybody knows this is a number. It's not just the picture of the angle. So the measure of angle 1 plus the measure of angle 2 has to equal 90 degrees. Now notice they are not equal. This one might be 30 degrees and this one might be 60 degrees. If 2 angles are complementary, they are not necessarily equal, but they definitely add up to 90 degrees. Now, supplementary is the same idea, except the 2 angles add up to 180 degrees. So the measure of angle 3 plus the measure of angle 4 is 180 degrees. So if this angle, let's say, was 50 degrees, this one would be 130 because they have to add up to 180 degrees. Now, the way you can remember the 2 words that I talked to my classes about last year was remember that C comes before S in the alphabet. So C is the smaller number. It comes first before the 180 degrees. So complementary angles are 2 angles, a pair of angles that their degrees add up to 90 degrees, and supplementary add up to 180. So here's an example of asking, are they complementary, supplementary, or neither? So I would take the 135 and the 45 and I'd add them together. If that sum is 180 degrees, they're supplementary. Otherwise, they would be neither. They cannot be complementary because this guy is already bigger than 90. So when I add them up, I do see 180 degrees, so they are supplementary. Same thing over here. I add the 67 and the 23, It does equal 90 degrees, so they are complementary. Now I want to pay attention right now, guys, because here's an example of kind of bringing algebra into geometry. So this obtuse angle is 3 times some number x. I don't know what that is yet. And this acute angle is 45. And they want to know what the x is to make this true. Now notice that that obtuse angle, if I keep adding on to it, I would end up with a straight angle. So the obtuse angle plus that 45-degree angle have to add up to 180. These two angles are supplementary because they make a straight angle. So if I take the obtuse angle, add it to the acute angle, I should get 180 degrees. The mistake a lot of my students made last year is they would just put 3x equals 45 and solve that equation. They're not equal. Look, that obtuse angle is bigger than that 45 degrees, but they do add up to 180 to make this straight angle that goes from H to K. Watch my cursor. I will trace that out for you. There is the obtuse angle. Add it to the acute angle, and I would be going in the opposite direction, 180 degrees. Okay, Woodruff bubble the 3x, subtract 45 from both sides, divide by 3, and the x would be 45. So if I take 3 times 45, add it to the 45, you should get 180 degrees. So how are vertical, adjacent, complementary, and supplementary angles are related? Well, adjacent angles are two angles that share a common side and vertex and do not overlap. Vertical angles will never be adjacent. Complementary and supplementary angles may or may not be adjacent. So let me explain that using this example here. These two angles are supplementary. They are not adjacent because they don't share a common side. However, these two angles, HJG and GJK, are adjacent and supplementary. They share a common side. They add up to the straight angle. They're both. So one more before we move on to triangles here. See, this angle is a right angle because it's got the little box in the corner. And it's saying find the value of x. Again, be careful here. These two angles are complementary because they add up to a straight angle. So this angle plus this one will make that 90-degree angle. They are not necessarily equal. Matter of fact, if you look at the picture here, they don't even look equal. So you're not going to set 2x equal to 28. You're going to take these two and add them to get to 90 degrees, which you'll see down here. You're going to Woodruff bubble the 2x, subtract 28 from both sides. You get 2x equals 62. You undo multiplying by dividing, and the x is 31. So if I take 2 times 31, I'd get 62. Add it to the 28, it will make 90. So that x has to be replaced with a 31 to make this work. Just before we move on, circle true or false. The sum of two angles that are supplementary is 180. S is the bigger letter, in quotes, goes with a bigger number, so the answer to that is true. Okay, the last thing we need to kind of just talk about today are triangles. Again, all done in 7th grade. Today we're just going through all of this and remembering. In the next couple of days, we're going to do some worksheets to remember all of this as well. Triangles can be named in two ways: by their biggest angle and the number of sides that are congruent, have the same measure. So if we look at this triangle up here, every angle is smaller than 90. He's called an acute triangle. If the triangle has a right triangle, notice the other two are acute, but the biggest angle is a right angle, it's called a right triangle. And if you look at this third triangle, you've got an acute and acute, but the biggest angle is obtuse. He's called an obtuse angle. So you can name a triangle and have the name for its angles be his first name. The second way, and the last name of the triangle, and if you reverse them, it's not a big deal, but if the last name here is you look at the number of sides. If there are no congruent sides, so if you were to measure these three sides, they're all different, then that would be called a scalene triangle. And notice that the triangle has none of these what are called tick marks, or you might hear the term hash marks on there. When those marks are missing, we're going to assume that is a scalene triangle. Now notice over here they put a single mark on these two sides of the triangle, which means they have the same measure. Those two sides are congruent. Then that is called an isosceles triangle. It's kind of a tough word to spell. I always tell my students there's an SOS in there. See that? Because it's so hard, you're going to throw up a flare and say, help me, SOS. So isosceles triangle. And then if all three sides are equal, it's an equilateral. Equa means equal, lateral means side. So equal-sided triangle. A triangle is obviously a figure that has three sides, three angles. And if you put a little triangle in front of three letters, if you saw that little mark, the little triangle, and then ABC, that stands for triangle ABC rather than angle ABC like we were doing a second ago. Alrighty. The other thing we learned about triangles last year is that there are three angles in a triangle, and no matter what triangle it is, those three numbers will always add up to 180. So inside of a triangle, there is always a total of 180 degrees exactly. So if you notice down here, the triangle has an obtuse angle that's 119, and it has an acute angle in the bottom right here at angle X, which is 43. To find that missing side, you can add those two up, and when you add those two up, it's 162 degrees. So in this triangle that has 180 degrees, you've already used up 162 degrees of it. So if you take the 180, subtract the 162, you know that angle Z has 18 degrees. So before we leave today, let's just kind of remember these ideas that we've just talked about. So first of all, if you wanted to draw a triangle with three acute angles and two congruent sides, it would look something like this. Notice all the angles are less than 90. And in order to let somebody know that two sides are congruent, have the same measure, you put the same number of those tick marks. So here is an acute isosceles triangle. And that's how you name it. So first of all, you look what was the biggest angle in there, and you call it acute. And how many sides are equal, have the same measure rather, or congruent, it's isosceles. So his first name is acute and his last name is isosceles. Using that idea that the angles add up to 180, if I tell you that there is triangle RST and I give you the measure of two angles, to find the third, you start by adding those two together. You've used up 92 degrees in this triangle that has to have 180. So take 180 minus the 92, and that third angle, which in this case is angle T, his measure, the measure of angle T, would be 88 degrees. You can kind of check yourself by taking the 55, the 37, and the 88. You add them in your calculator, you'll see that they will equal 180 degrees. Now, I don't know if you've ever played billiards or pool, but in pool there is this rack that you start by putting all the pool balls in, and to kind of line them up and put them in a triangle. And it is this shape, obviously, and it does have 60 degrees like that. And they're asking you, what is the measure here? Well, if you take the 60 and the 60 and you add them together, you get 120. You subtract that 120 from 180 that the triangle has to have, and that missing angle would be 60 degrees. By the way, this is actually your rack in pool is an acute equilateral triangle. So how can triangles be classified? How can they be named? They can be either acute, right, or obtuse for their first name, and scalene, isosceles, and equilateral for their last name. Okay, so we're going to, not today, not for the first day, but the second day we're going to do a worksheet that has you finding the missing measures in triangles. But I just wanted to stop here today and try a couple. So I'm going to ask you right now to pause the video and see if you can figure out how to get this measure of the angle that I'm tracing here. It's this right-hand angle. See if you can figure that out. So pause and give it a go. Okay, guys, let's see. It takes a couple of steps to get there. So at first you're looking at this triangle and realizing you've only got one measure. So you can't use that idea of them adding up to 180 because you need two. But notice over here that this obtuse angle and this acute angle will make a straight angle that I'm tracing. So the 140 plus whatever this angle is here would have to add up to a straight angle, which is 180. So 180 minus 140 would give you 40 degrees right here. So that would kind of be the first step. Once I have that measurement, I could add these two together. 63 plus 40, that gives me 103. I've used up 103 inside the triangle. So 180, take away that 103 would be 77. And 77, now again, here is going to make a straight angle over here. So the angle I'm tracing is 77. The one on the right-hand side would add with that 77 to 180 degrees. So if I take 180 minus the 77, it's get 103. Kind of interesting to see that number. Okay, let's look at that second one now at the bottom. Again, if you didn't have a chance to take a look at this one, can you get this measurement up here? It's kind of a bit of a puzzle, and you have to do some steps to get there. But if you want to pause the video and see if you can get yourself up to that angle, only knowing these two. Okay, let's see what you did. I'm going to uncover my answer over here. And I put my first, second, third, and fourth. So the first thing I did was use the idea of vertical angles here and put the 75 up here because they're congruent. The next thing I did was I came over here and realized that these two are supplementary. They're adjacent angles that add up to a straight angle. So I took 180 minus the 115, and I got the 65. Now if I take these two and add them together, I would get 140 degrees have been used up inside this triangle. Well, if 140 have been used up, this would have to be 40 to get to the 180. 180 minus 140 would get me to the 40, and then vertical angles would bring the 40 over here. So today what we've been talking about is seriously things that we did in 7th grade, but that was a long time ago. So that's why we're spending a little bit time today to make sure that you remember how to do angles and talk about angles inside of triangles. That's it for today. Tomorrow we'll do a worksheet that will deal just with the angles and naming. The second day we will bring in the triangles. I hope you have a great day, and don't forget there'll be a notes page available all filled in, and you can always come back and watch this video or rewind and listen to parts of it, whatever makes it easier for you. Have a great day, everybody.